Transformers are at the core of the current AI revolution, and the question of how you make them go faster and how you make them take more tokens in and get more tokens out is, quite frankly, a billion-dollar question that hundreds of startups and massive companies are racing to solve. And a lot of people think that companies like Nvidia will just always be at the forefront, and they think that no one will ever touch the capability, the price, and or just the velocity of the technology that they're releasing. Specifically, their AI GPUs like the H100 or the B200, or even the RTX 4090. The irony of which most of these can't actually even play Crysis or even do graphics things anymore, when Nvidia's entire claim to fame was actually revolutionizing graphics. But today that is entirely changed. And I know we've seen other specialized chips emerge. For instance, Grok's LPU just about a year ago was an immense step forward. It showed us that, at least for inference, we could wildly accelerate past anything we thought was even capable. Google has been trying to do this with their TPU systems for quite some time, but curiously, their yet-to-be-released TPU v6 actually has less flops, basically compute capability, than the H100, which at this point is actually an outdated NVIDIA GPU. And today, I'm incredibly excited to talk about another immense step forward. Some would say a step change or an order of magnitude leap forward, and that is with a startup called Etched. So Etched has been known to be around for some time. They initially announced they were working on transformer accelerators back in March of 2024. And what's wild is today they're showing us what they've been working on. So I want to get into how much faster this is than Grok's LPU, what this means for the future of AI, and more importantly, what it means for the future of AI-specific hardware and just specialized hardware meant for both training and running inference on massive AI models, and what that might look like in the next maybe 5 years or so. So welcome to AI Flux, let's get into it. So what Etched released today is called Sohu. This is what they're calling the fastest AI chip of all time. So they're saying here that with over 500,000 tokens per second running Llama 70B, specifically Llama 370B, Sohu lets you build products that are impossible on GPUs. One 8x Sohu server replaces 160 H100s, and I'll get to what that equates to in Grok LPUs in just a bit. Sohu is the first specialized chip, or ASIC, for transformer models. So just like their Bitcoin ASICs, this is an ASIC only meant for running inference on transformer model. By specializing, we get way more performance, Sohu can't run CNNs, LSTMs, SSMs, or any other types of AI models, only transformers. And what's interesting, and this is why you should go and watch John Coogan's interview with the founders of Etched, but the real key to the innovation that Etched has nailed here is that basically everything worth covering in AI is transformer-based. We love Mamba, but transformers are basically the entire industry right now. And the thing is when you specialize on hardware, you actually get to simplify the software you're using as well. And what another kind of second-order win that Etched has here that they don't really talk about a lot is most of the AI tooling being built currently is based on PyTorch or TensorFlow, and these both have interesting trade-offs in terms of training and inference. And the reason advancements like TensorRT and VLLM are so important is they let you use way more of the GPUs that you're paying a ton of money to train on than using kind of standard software tooling like just PyTorch or TensorFlow. And the big deal there is if you can get even, a 10 to 15% bump in performance, you're training faster, you're getting higher utilization, and things are just going to go faster. So their idea was, well, if most people are just doing stuff with transformers anyway, why not create the best hardware and then, as a second order effect, the best software? So what they're saying here is today every major AI product, ChatGPT, Cloud, Gemini, etc., is powered by transformers, and within a few years, every large AI model will run on custom chips, and more importantly, be trained with custom software written for those chips. This chip looks pretty cool. I mean, this is a rendering, but it's cool how small these are, and we know that 8 of them fit into a reasonably sized server, and it's probably going to be smaller than the B200 released by NVIDIA. Sohu is 10 times faster than NVIDIA's next generation B200 that they haven't even let really anyone use yet. One Sohu server runs over 500,000 tokens per second on Llama 370B, 20 times faster than an equivalent H100 server running at 23,000 tokens per second, and 10 times faster than a B200 server running at 45,000 tokens per second. And the rough number from Grok is around 1,400 tokens per second, but the tough thing with Grok is they're not really big on sharing how many LPUs they consider a single unit. Basically, since the Grok LPUs have so little memory on board, you have to network a bunch of them together to actually work. So they are highly performant, but roughly a single LPU is maxing out at around 400 tokens per second. And they actually just, like today, published this, that this is what they've achieved so far. And it's funny that they're kind of playing catch up now since they're not kind of the hottest AI accelerator chip startup on the block anymore. So again, 20 times faster than H100s, which is kind of wild. And this is looking at 8 units of a GPU or a accelerator chip as well. So that's kind of the control here. And the biggest claim I think Etched has made is that they're claiming GPUs just aren't getting better. They're just getting bigger and they want more power. So here they have everything on the board. So they have everything from NVIDIA, AMD's MI300X, which of course no one is actually using because the tooling is so bad, Intel's Gaudi 3, Amazon's Trainium 2, etc. So we have everything on here, even Google's TPU v5. The irony is the TPU v6 actually is only like around 10% better. And the claim they're making here is that it took 2.5 years to only get 15% better, at least when we look at FP16 teraflops per second per millimeter squared of chip. So this isn't raw performance, this is density of performance, which in certain cases is a much more impressive metric or much more important metric because that directly scales to how much power a lot of these use and more importantly, how much heat you can extract from them while they're running after they use all of that power. And the biggest bet that has paid off for Etched, again, was just betting on transformers. Obviously, Mamba's really cool. There's some other really interesting RNN-based models, but transformers have continued to emerge as the most useful and I guess valuable model to build on top of when people are building these large language models. And even models that do visual things like Sora or Stable Diffusion. And now for a bit more insight, I want to hop into their website. So they have another beautiful picture of this new incredible chip. And I think rightfully so, they're saying that Etched is making the biggest bet in AI, which is that they're going to have the best hardware. It's going to be better than anything NVIDIA can make. And one of the really interesting points that was made in this sort of interview with John Coogan and the founders was that the reason Etched isn't worried about NVIDIA making a dedicated chip is that if they specialize the current Blackwell B200 anymore, they would just start eating into their own market segments. There's no reason for NVIDIA to make like a transformer optimized version of the B200 because then it would just cost them billions of dollars and just mean they couldn't recoup development costs that they actually used to create the first kind of generalized per se B200. And again, the irony is that most of NVIDIA's most expensive GPUs and the ones that have the most power, like quite frankly, literally don't do video anymore. Like there's not even an HDMI port on the back of them. They do none of that. You plug them in and they just kind of roughly act oddly similar to a TPU. I mean, it's easy to make fun of TPUs because you can't really do much with them, but the best chips from NVIDIA are actually quite similar at this point and are running into very similar limitations. And another part of this big bet they're making is about scale. So one interesting thing is they think in 5 years, these models will potentially become smarter than humans. And one thing that's interesting with this, and scaling is one of the bigger limiting factors here. For instance, Meta used over 50,000 times more compute to train Llama 3 400B than OpenAI used to train GPT-2 in 2019, which is completely nuts. So by feeding AI models more compute and better data, they get smarter, but scale is still something that's going to make this really hard if we do want to match human intelligence in the next 5 years. So money is being spent on scale, not necessarily the fastest chips. And the other thing is that scaling and fastest chips don't necessarily play nice if that chip you're using can't actually be shoved into a data center that's large enough to fit enough of them to actually scale. The other big thing here is, like they've said before, GPUs are hitting a wall in terms of their density of performance. Sure, we can make them bigger, we can have multiple chiplets that talk with really fast interfaces to one another, we can have 2 of them on a die, 4 of them on a die. That's why these are getting so big, and the interesting thing is they're not really getting that much faster when you look at the speed per millimeter squared. And obviously, Etched is not the first to come up with the idea of creating dedicated, specialized AI chips. Obviously, we've seen Tens, Torrents, Grayskull. We've seen everything from Grok, the plate-sized accelerator chips from Cerebras. We've seen AMD's lackluster attempts, obviously NVIDIA's GPUs, Google's TPUs, which have been arguably kind of the longest running AI accelerators in existence. And what's interesting is none of them have ever built an algorithm-specific AI chip, like an ASIC. These are just accelerators that do matrix kind of matmul and can do ReLU operations faster, but it's not an ASIC. And it's kind of cool that now we've seen this kind of pivot where this is a pivot that happened in Bitcoin mining years and years ago. And it's important to understand that a specialized GPU or a specialized processor and an ASIC are still two very different things. Like this ASIC can literally only do basically one thing, or one set of operations, which in this case are the operations required for transformers. So it's really expensive. They're really hard to make, but they're really freaking cool when they work. And as someone who has half an electrical engineering degree, I can appreciate a good ASIC when I see one, because I spent months working on a pretty bad SHA-256 ASIC as part of a final project. But we'll talk about that in another video. And again, to be clear, this is all based on Llama 3 performance. The other big thing here is, so they don't mention this in their Twitter post, and I don't know, I have no clue why they didn't do this, but yeah, they say here and clarify that benchmarks are for Llama 370B and FP8 precision. No sparsity, 8 by model parallel, not the first rendition of Llama. And as they say here, Sohu only supports transformer inference, whether Llama and Stable Diffusion 3, etc. They support all the models and can handle tweaks for future models. And as I say, they can only run the algorithm for now. So the last thing I want to go over is why there's so much density in these chips. Obviously, the NVIDIA H200 is incredible because it's so close to that magical 1,000 teraflops of FP16 compute within one unit. And basically it boils down to the fact that most of a GPU's die area is devoted to programmability, is mostly focused on programmability, not necessarily transformers. So it's focused on letting you put something together and then run it, but not only just focus entirely on running it. And when you get down to it, when you look at just the number of circuits it takes to do that, when it comes down to just making something as simple as like a multiply add circuit, or only use these structures for running a model, you inherently get much more performance. And this is why by only running transformers, Etched can fit more flops on their chip without resorting to lower precision or sparsity, which is a common thing you have to do when you're running very high performance inference on NVIDIA GPUs. And a really interesting misnomer, and we've covered this on this channel before, is that you'd think inference is bottlenecked with memory bandwidth and not compute. But depending on the architecture of what you're actually running on, a lot of times that actually isn't the case. And with this new etched Sohu chip, it definitely isn't the case. So on GPUs and on Sohu, inference is run in batches. And each batch loads all of the model weights once and then reuses them across every token in the batch. Usually LLM inputs are compute bound and LLM outputs are memory bound. But when we combine input and output tokens with continuous batching, the workload becomes very compute bound. So basically, once you can actually represent it as a stream, it really just comes down to compute. And what they've already mentioned before is only around 3% of an H100 is really intended to be dedicated to inference, just in terms of the literal circuits that are etched into it. So here, this is an example of continuous batching of prompts and completions, which is actually pretty interesting. And yeah, so as a result, you get far better throughput on the etched Sohu chip than an H100 or a B200. And it all just has to do with how we're actually accessing the information and the fact that it's not kind of batch in, batch out, and that we can push in what we want and then basically always get the output that we would expect as well with that input. Now, I'm not going to mention the software as much. And again, I think you should definitely go watch some of my recommended clips below from John Coogan's video with the founders, where they describe this. Again, the whole idea is utilizing more of the GPU. And the other thing is that the custom software tooling used to train models that is below the level of, TensorFlow or PyTorch, it's kind of accepted that's been maximized. And the only way to get more of it is actually to build custom chips for training models. So there's actually quite a chance here that NVIDIA could really fumble once it becomes kind of a known quantity in terms of how expensive it is to make custom chips like this. Like at some point, it might be cheaper to say, yeah, we'll make a custom chip for our model, and then we'll think about how much money we're going to spend on the actual engineering, the power cost, etc. And there could be a time where the idea of doing this on NVIDIA GPUs is just kind of not smart anymore, because it's like, well, we know we have the transformer models. No one's going to give you money to train anything else than a transformer model, because so much money has gone into making these that the idea you would come up with something better outside of that is just, for now and for the near to distant future, just not very likely. And the other cool thing is that to use their chips, this comes with a software platform that allows you to use them and even work below them. And there's no more need to kind of reverse engineer how it's working. So for instance, with things like Grok, this is meant to be deployed on bare metal. And the idea here is that this is a holistic offering. And obviously, Etched is the first to do this. It'll be interesting to see what's going on here. They've directly partnered with TSMC for their 4nm process, and they have enough HBM and server supply vendors to quickly ramp their first production round. So it's going to be really cool to see this. I'm going to do my best to try to get my hands on at least some kind of interface to try using these. I think they're going to be even faster than Grok, and I think this is more impactful than Grok. Like Grok was a massive step forward, but they kind of missed a little bit when it turned in terms of how people will interact with these chips and thinking more about specialization both in hardware and software. So I think Sohu will change the world. I do like looking at other sort of architectures just from a research perspective, but I think in terms of what will change the world and what will sort of solve scaling issues, I think chips like this, piggybacking on top of how much progress we've made with transformers, will be the path forward. Like for instance, one of the only real benefits of Mamba and RNNs and these kind of other exotic models is because they solve some of the scaling issues. So the curious thing is if you can just solve the scaling issues of transformers and not have to like rethink more base architectural attributes of how we make these large language models, it's an incredible combination of engineering wins that I think might actually push us to a point in the next 5 years where we maybe reach a moderately okay intelligence of a human. Where we reach maybe like an average intelligence of a human. Maybe not a PhD or like a software engineer for my sake, but we'll just have to wait and see. So I'm curious what you think about this model. Do you think it's actually going to be Grok? Do you think this is actually going to be the death knell for NVIDIA and their complete domination of the AI markets right now, at least if you're buying hardware to train a model? Do you want to use this? Do you think that this is going to be bad because it's just going to enable closed source AI companies to use it? Let me know in the comments below what you think. As always, I hope you learned something in this video, and we'll see you in the next one.